Hey friends, haven't seen you, I feel like, in forever. We haven't talked in a long time, and that's okay. But you know what? I thought that I would bring you on an adventure of mine. One of my favorite things to do as a kid when I was your age on hot summer days. And I know we're not having hot summer days, but as you can see outside, we are having a pretty day. And even though it's not the best idea to go outside right now, one of the best things that I thought I could do to make myself feel better during this time is to make one of my favorite summer treats. And now, one of my favorite summer treats I want us to think about for a second. It's made of something, and I'm going to show you some of the things. And if you think of it before I tell you what it is, I want you to go ahead and say it. But I've got some ice cream, of course, a nice root beer, and then also inside this root beer we call carbon. There's carbon gas, carbon dioxide in here. That's what gives it its fizz. But I thought, why not make one of my most favorite treats as a kid? You can see my ice cream here. I might even take a little taste first. Just the way I remember it. So I'm gonna stick my ice cream in this cup here. But as a kid, I loved it. And I'm sure most of you have had these as well. Now, when I was a kid, I called these ice cream floats or root beer floats, whatever you want to call them. I've even gone to the store before and got them like at Sonic or like at the gas station, something like that. As you can see here, I'm putting my ice cream in the cup. I can't get it off all the way. I guess I'll just have to eat the rest of it. I'll save it for later. You can see I also have my root beer too. Pour my root beer inside, and you can already see it foaming up like crazy. You can already see it foaming up like crazy. What I'm gonna do is I'm gonna take my spoon, give her a stir or two. I accidentally put too much in here, and that's okay. I'll still drink it all. But these are some of my favorite things. And all these ingredients, when they come together, the carbon dioxide that makes this foam that you can see, the ice cream, and then the root beer, they're all different states of matter. And I figured, you know what? Since these all three are made of matter, why don't we do a lesson talking about states of matter and explaining our three different ones? Let's go back and look at one more. Hey friends, we're back kind of in my teaching area. The sun's shining on me. Like I said, it's a gorgeous day. Got my root beer float, ice cream float, whatever you want to call it. Instead of my coffee. I'm sure if I added a little bit of coffee in, it'd be really good. But anyways, before we dig deep into the states of matter, and I know most of you are thinking, Mr. Reed, I already know the states of matter, and that's okay. But we're going to talk about some characteristics of states of matter and how we can define them rather than just looking at water and saying, oh, that's a liquid. Well, how do we know it's a liquid? That's the question we're going to be answering by the end of today. But I want us to look at this piece of paper. As you can see, I have a straight piece of paper, no writing, no tricks. I have some scissors. These are crazy scissors. But I want us to imagine if we have a strip of paper, we have this paper, and I'm going to cut this piece of paper in half. And to make it a little bit easier, I'm going to fold it. I can see my lines that I'm cutting against. But I have my paper. I fold it in half, and I'm just going to cut it. And I'm going to use my trick where it just glides, and now I've got two pieces of paper. Okay, now I have two pieces of paper. I've cut it in half. Now I'm going to take this one half again, and I'm going to fold it up one more time, and then I'm just going to cut it again. Why not? So let's cut it again. So I'm going to keep cutting it. See if I can go all the way down. Keep cutting it, keep cutting. And I know what you all are thinking, and I'm going to keep going and keep going. I know what you were thinking. At some point, it seems as if I'm going to run out of paper. However, what you don't know is that even though I might look like I run out of paper, I'm actually not going to. The thing about matter is that matter cannot be created nor destroyed. That's a science law that we might learn. But though what's going to happen is I can keep folding it and I'll keep going. You can see me. I'm going to fold it again. And I can keep cutting and keep cutting and keep cutting. But eventually, something's going to happen. And what's going to happen is my scissors are going to end up being way too big to keep cutting this paper. And it's not because I have these crazy looking scissors. I dropped a piece. It's not because I have these crazy looking scissors. It's just because at some point I'm going to need a microscope to see what's even left. And all the matter that is here, though I can't visually see it with my eye, it's still there. Even when I cut it into the tiniest piece, there's still more that technically I could cut if I could get down to it. But I'm not going to. As you can see, I'm struggling just like the way it is. But there's still going to be pieces of matter left that I can't see. A Microsoft would be able to see. I could keep going and keep going. It's never going to stop. It's an infinity amount. And so today with matter, we're going to talk about what defines them, how does matter not go away even though it looks like it's going to go away, what we can use to see those types of things, the particles that make matter, what they look like, and all that different stuff. Stay with me. I'll be right back. Hey guys, sorry, I had to go get some materials for our lesson today. Anyways, let's talk about matter, okay? Let's get down to the matter of business. What's the matter, you say? Well, matter actually can be found in many different shapes, sizes, or forms. So for example, shapes. What shape is this? Rectangle. Sizes. You can even see a shape here. Size. It's got a pretty big size. And it's even got some maybe form to it, right? Now then, maybe ice too. Ice has form, and that form can eventually what? Change, right? So for example, my ice cream, my root beer, and the gas inside of my root beer, all that makes the root beer fizz, which I'll show you in a second, so I don't recommend doing that at home. We can't see them. You can't see this gas. I can't see this gas. I can see the liquid, but I can't see the gas. But I know it's there. Now my question for you is, how do you know it's there? How does Mr. Reed know it's there? Well, for example, if I take my root beer and shake it up, not a smart idea, right, Mr. Reed? If I take it up and shake it, and I open it, hear it already? Do you hear that? Here it comes. It's coming to the top. You can see it rising. If I put my hand on top, what do I feel? I feel the gas coming out. I can hear the gas coming out. You heard it as well. But matter's there, even though we can't see it sometimes. Now, simply put, if you want to take notes with me, you can just get a pencil and a piece of paper. Let's share a screen with a whiteboard. Share that. Now, in all, let's say that matter is simply enough, just like every physical thing that something is made out of. So we have matter. Matter. What is matter, you said, Mr. Reed? Well, matter is the stuff that things are made up of. Things that make up stuff. And I know that sounds silly, but I want you to think about it for a second. Matter is the stuff that makes every physical thing that we can
Here, C. Anything that has mass and takes up space. Now, mass is different than weight. What is mass, you say, Mr. Reed? Well, mass is actually the weight of something, how heavy something is. Now, that's different than weight because technically weight is about gravity and the pull towards the center of the earth. Weight changes. Let's say, Mr. Sean Crawford, a good friend of mine in class, a good student of mine. Let's say Sean weighs, I don't know, 50 pounds. I don't know how much Sean weighs, but let's say Sean weighs 50 pounds. And he gets on a scale here in the United States in Memphis, Tennessee, and he gets on a scale and it says 50 pounds. Now, if Sean flew all the way to the moon and he got on a scale in the moon, it would not say 50 pounds. It would say something different because technically your weight, how much something weighs, is the technical gravity, the pull that gravity has. Now, mass is just how much something weighs and the amount of property that is there. And the particles of matter are impossible to see. We can't see the small particles that make up matter. But they're still there. And technically, we would need something that can look real deep into something to be able to see it. Now, what do we call that again? It's a scientific tool. And if you're thinking what I'm thinking, it's called a microscope. Now, a microscope, let's see here. I'm going to stop my share here. Now, microscope, let's go to here. Now, a microscope, if you've seen one before, this is a microscope. A microscope, you can put cells under there, all these sorts of things. These are microscopes, and microscopes are used to see things that our eyes cannot. And once we put our eyes up to this area right here, we put our eyes up to this and we can see something that's been set here, and it zooms in really close. Let's look at a dollar bill. Or no, let's look at a leaf under a microscope. Now, if you see, this is what a leaf looks like under a microscope. Now, these are made of cells, and that's not what we're getting into today. Here's another leaf structure. This is what a leaf looks like. Now, when you look at a leaf, this isn't what a leaf looks like. It looks way different. But these are the particles that make up physical things. And we need a microscope to be able to see some of these particles, and they won't go away. Now, matter is described in two ways. It's described and classified by mainly its properties. And the two ways of these properties are a characteristic and a feature, or feature, either way, a characteristic or feature. Now, I want you to think, what is a characteristic? Maybe name a characteristic of you or a feature that you might have. So, for example, my characteristic or my feature would say how dope my hair is, right? My hair is always on fleek, right? That's my feature. Or my ears are really big. That's a characteristic. That's a feature that I have. Or that I'm super tall, right? I'm 6'3". That's a feature. That's a characteristic of Mr. Reed. Or I could say this dollar bill here, what color is he? He's green. Just like some of you may be a different color, right? Mr. Reed's got a white color. Some of you may have darker colors, black colors. Who knows? We all come in different ways. And these are all features and characteristics that define us. These are properties. Give an example of what your property is or what your feature could be. Now let's look at some things real quick, and I don't have all of them. But what we're going to use is we're going to ask ourselves two questions. Two questions. And the questions that we're going to look at is, number one, what does it look like? And number two, how does it feel in your hands? Okay. So first, I've pulled it up a lot. Let's just talk about this dollar. I know we all love money, right? Mr. Reed loves money. You love money. Everyone loves some moolah, baby, right? So I got this cash money right here. What does it look like? You tell me. I've got it backwards for you. What's it look like? Screen. Rectangular. It's got a picture of somebody on there. Bonus points if you can name who it is on the dollar bill. Bonus points. But that's what it looks like. How does it feel in my hand? It's pretty what? Pretty light. I mean, I can pick it up with my pinky, right? I know it fell off, but I can pick it up with my pinky. How does it feel? It's kind of smooth. The new dollar feels crisp. I love a brand new dollar bill. Ooh, they're crisp and they sounds good and it smells like money. How does it feel in my hands though? It feels smooth. It feels like paper almost a little bit. Now let's look at something else. Let's look at Ice, Ice Baby. That's a song that's older than Mr. Reed. Ice, Ice Baby. Ooh, I dropped my ice. Here's a piece of ice. And man, I can't, what does it look like? Well, if you could see here, this ice has kind of got a weird shape, kind of half circular, clear, whitish. And let me just tell you something. Most of you already know. How do you think it feels in my hands? Boy, it's cold. And not only is it cold, you can see it. What is it doing? It's wet. And it's starting to do what in my hands? Because my hands are warm, it's starting to melt. We talked about that last week, how heat can change things. The heat from my hands is making that ice what? Turn into a liquid. We'll talk about liquids in a second. Now, if I had a balloon, I'd blow up a balloon. And I'd hold my balloon. Let's pretend I have a balloon here. I blew up my balloon. And if I'd let it go, what would be inside of that balloon? Gas, air that came from Mr. Reed, right? Or to show you another gas, I'm going to take a candle here. Don't try this at home. I'm going to light the candle. You can see I've lit the candle. And hopefully you'll be able to see it. But, oh, you can see it just a little bit. What do you see coming up? Or watch if I blow it out. What do you see? What you see is gas, right? This is smoke. Gas coming from the candle. Whew. Oh, Lord. I'm going to make my smoke alarms go off. But anyways, so we have gas that comes from the candle. Gas, that smoke comes up. And last I showed you a second ago from my root beer. If I shake it up, how did that smoke feel, by the way? Well, smoke can feel hot. I can't put smoke in my hands. Can't do it. Whew. How does smoke feel? I can't put it in my hands. But what did it look like? It was gray. I was visually able to see it for a second. But this smoke, what does it look like? What does this gas look like? Well, you can't see it. What does it feel like in my hands? I don't know what it feel like. Did you hear it? Maybe you can hear it. Hear that fizz? That's a gas. I can hear it. I can maybe feel it if I had my hand on top of it. Maybe if I fill up my glass here that's I can feel just a little bit fizzing up, right? Or precious, precious Lysol. Thanks, Janiyah, for the Lysol, by the way. But you can hear it. Hear that gas? It's almost empty. Hear that gas? Hear that liquid? Yeah, that's a gas as well. What does it look like? It's hard to see. How does it feel in my hands? I don't know. I can't put it in my hand. But these are all different ideas that we have about what matter is like. Now, if you stay with me here, friends, I'm going to share a screen again, and let's go back to a whiteboard. Here's our whiteboard. Let's make it larger. Now let's clear all our drawings. So if we take our whiteboard, physical properties can be observed. So observed means seen. Observed, don't forget to take notes with me, pencil and paper. That's the best way to do it. Observed and measured. Now we can measure them like we talked about through size, color, and shape. And we can do that through our senses. Now, can you name all 5 senses? Let's see if you can. Now, if you're able to name all of them, it's hear, sight, smell, taste, and feel. Those are our 5 senses, right? And so our 5 senses, we're able to use these to describe, observe, and measure properties. I spelled it wrong. Properties, right? And so matter can be in one of these 3 states. Can you name these 3 states? Let's clear our drawings. Our 3 states are solid, liquid, and last but not least, gas. So we have these 3 properties of matter: solid, liquid, or gas. Now, let's talk about solids for a moment. Let me get my eraser. Let's talk about solids for a second. Solids, what's cool about solids is that solids have their own shape and take up a specific amount of space. So for example, this dollar bill, it has its own shape. You can see that shape. We've said this shape is what again? It's a rectangle, right? So it has its own shape and it takes up a specific amount of space. No matter what I do, I could crumble up this dollar and it might change the way it's shaped, but it's still going to take up the same amount of space. I can't make it change the amount of space it can take unless I did something crazy to it, which I would never, right? A book. So here's a book, okay? I don't have a pen, but a pen or a pencil, a table that you're on right now, these are all solid. Can you name a solid? Great. A solid takes up a space and a certain amount of space and it doesn't change and it has its own shape. Now, our second example of properties of matter is what I would call a liquid. L-I-Q-U-I-D. Liquid. Now, liquids, that's a bad Q. I apologize, friends. Now, liquid, it has 2 specific things as well. Liquids take up space. They take up a set amount of space. They take up a set amount of space. But guess what? It does not have shape. Doesn't have a definite shape. So for example, I know my handwriting's bad. I apologize. I lost my stylus. But look at my liquid here. Now, right now, it looks like it's in a cylinder because it's in a cup. It doesn't have its own shape because technically I could pour it in anything. If I poured it in a rectangular bowl, it's in a circle now. And as a matter of fact, why don't I just go ahead and go get one? You can see how this is a rectangle. If I pour this liquid into the rectangle, it then turns into A rectangle, right? So it doesn't have a definite shape. The shape can change depending on what's holding the liquid. But I can still drink it, right? And last but not least, I should just clear all my drawings. Here we go. Last but not least, we have gas. Now, what's cool about gases is number one, they have no definite shape. Gases aren't held to a single shape. We saw the smoke going and it was just kind of doing its own thing, right? And not only do they have no definite shape, they also fill any space. I can put that gas into anything and it will take up whatever space is needed. Whatever space is in there, that gas can take it up. Whatever the container it's in, it'll take up that space. When I blow up a balloon, it takes the space in the balloon, right? The more air, the bigger the balloon. Now I want you to think back to my experiment with heat. My experiment with the balloon rising and the heat, the hot water and the balloon rising and what it did. We talked about particles in that, and I was preparing you for now. Particles are in matter, and they're constantly doing what? Moving, right? Now, in a solid state, particles, they're confined, they're tight, they're staying close. They're like, I can't move, okay? Look. See them? They're in a tight space. They don't move a ton. That's why solids stay in that shape. But however, when it turns into a liquid, they kind of get a little bit more wiggle room. They're like, okay, maybe I can do a little bit. I can move just a little bit. These particles are always moving, no matter what state they're in. And last but not least, what happens with that gas state? Now, we talked about what those particles begin to do. They spread into what? And I said, when you get super active and excited, what do you want to do? Go crazy, right? That's what these gas particles are doing. The gas particles are able to move freely. They can go wherever they want to go, right? Now, let's think about this ice cube that Mr. Reed has. These ice cubes are made of water particles, and you can see water drip. There it was, right? Water dripping. These particles are close together and they're not moving very much in this solid state. That's why solid keeps its shape. It stays in that same area and the particles aren't moving very much. Now, when the ice is melting, as it is now, you can see that it becomes a liquid. And as that liquid, they're starting to move a little bit more. The particles can move around just a hair more. And once the water evaporates, it turns into what? Water vapor, right? We call that last one what? Yeah, we call that a gas, the state of gas, right? And so that gas, sorry friends, I got water on my computer. That gas is still made of water particles. H2O, remember? It's still made of water particles, but those water particles are now moving around crazily. And they're filling up whatever space that they want to be in. And even though we can't see them, that's okay. They're still there. And you can do this at home, and I'll let you think, and this can be your at-home experiment. And I'll leave you with this thought. When your mom makes Kool-Aid or coffee or tea, she puts something in there sometimes. She may put Kool-Aid powder in the water, sugar in the coffee, sugar in the tea. And what she does is she'll stir it up, right? And can you still see the sugar? Can you still see the Kool-Aid powder? No, you can't. What does it do? I know you've heard of that word. It dissolves, right? It's not there anymore. And it spreads out evenly and it makes its own thing. But guess what? That sugar, that Kool-Aid powder, It's still there. You just can't see it. Crazy, right? Or if you take salt, if I took salt water from the ocean, if I took a scoop of salt water from the ocean and I put it on my stove, that we've done many experiments so far on it, and I boiled that water, you know what would stay? Particles of salt would stay left in my pan, even though I wouldn't be able to see it before. They're still there. If you add air to a basketball or a soccer ball, it makes it bigger. We know that there's air in it when it can bounce when we're able to kick it. Though we're not able to see that air, we can see the evidence of it, or we can taste the evidence of sugar in tea. I'm gonna leave you with that thought, guys. We'll come back tomorrow and we'll talk about the properties of matter a little bit more. But until then, miss you guys. Stay safe.